repeating decimals. So in the last section, we looked at terminating decimals. Those were decimals where the decimal part of the number terminates, right? It stops. But not all rational numbers can be represented by terminating decimals. In fact, we saw last time that in order to be represented by a terminating decimal, your rational number in simplest form has to have denominator made up with prime factorization consisting only of 2's and or 5's. Okay, so for example, if I wanted to convert 2 11ths into a decimal using long division, that's asking me to divide 2 by 11. And so when I divide, we just bring the decimal up, right? So 11 goes into 20 one time, and we're left with 9. We bring down the 0. 11 goes into 9 8 times, and we're left with 2. And we can always keep adding zeros here. And so you can see if I bring down that 0, I'm just repeating the process that I had up here. It just loops. So I'm just going to get 1 8, 1 8, 1 8. This is called a repeating decimal. And the repeating block is called my repetend. In this case, my repetend is the 1 8. So we write this as 0.18 with a bar over the 1 and the 8, and that tells us that the 1 8 is what repeats. All right. Okay, so most of us have seen what we just did, writing a rational number as a repeating decimal. But what about going the other way? What if I give you a rational number or a repeating decimal and ask you to write it in the form A over B? So this is going to be a little trickier. So we're going to take it one step at a time. So the first thing is that I want to do is call this number something. So let's call it X. So X is going to be 0.5 repeating. So X is this 0.5555 on and on and on. Okay, so the first thing I want to do is multiply both sides of the equation by 10. Here I'm multiplying by 10 since there's one digit that repeats. If X were equal to, say, 0.18 repeating, we'd multiply by 10 squared because there are two digits in the repetend. Okay, so we're always multiplying by 10 to the power that comes from the number of digits repeating. All right, so I'm going to multiply both sides by 10, and let's see why that's helpful. So I get 10x equals 5.55555. Now, I want to get rid of the decimal, right? I want the stuff to the right of the decimal to go away. And so this is helpful because what I want to do next is subtract x from both sides, but I'm going to do it in a clever looking way. So on the left-hand side, I'm going to subtract x, and on the right-hand side, I'm going to subtract the 0.55555, which is what x is. Okay, so this is nice because on the right-hand side, those numbers after the decimal point all cancel out. So I just get 9x equals 5, and so now I just need to solve for x by dividing both sides by 9. So x is 5 9ths. And if you pull out your calculator, and do 5 9ths, you can see that it's 0.5 repeating. All right, so that's a cute little trick. Let's look at another example. Let's try writing 0.435 repeating as a rational number. So again, I want to let x be the number I'm looking at, 0.435 repeating. So that's 0.435, 435, etc. All right, so that was my first step. My second step was to multiply both sides by 10 to the power of the number of repeating digits. In this case, there are 3 repeating digits, so I'm going to multiply by 10 cubed on both sides. Okay, so 10 cubed x equals 435.435, etc. All right, let me write this a little clearer. 10 cubed is 1,000. So I get 1,000x equals 435.435 repeating. All right, my next step was to subtract x from both sides. So I had 1,000x equals 435.435, etc. Now I'm going to subtract x from both sides. On the left, I'm going to write it as x, but on the right, I'm going to write it as 0.435435. Now notice the decimals line up because we multiplied by 10 cubed. If I had multiplied by 10 squared, for example, my decimals wouldn't line up nicely, so that here they cancel, right? So they all cancel off to the right of the decimal, and so on the right I'm left with 435, and on the left I have 999x. And finally, I want to solve for x. I have, that's a 3, number 4. Solve for x. I get x equals 435 over 999. So again, let's check with our calculator. 435 divided by 999 gives me 0.435435. All right, so it worked. Okay, I want to look at one more kind of repeating decimal, and that's the case where the repeating doesn't start immediately after the decimal point. Okay, so we're going to use a strategy that we've been using all of this section. We're going to turn it into a problem we know how to handle. So in this case, the problem we know how to handle is the problem when the decimal point is right after, when the repetend is right after the decimal point. All right, so let's look at the example. I'm going to write 2.3 with 4, 5 repeating as a rational number in the form a over b. So my first step is to turn it into a number that I know how to handle. A number I know how to handle is 23.45 repeating. So if I could move that decimal to the right one place, that would help me be able to handle this problem. How do I move the decimal to the right? I'm going to multiply by 10 to the first. Okay, so in this case, I'm going to multiply by 10 to the first. If I needed to move that decimal more than one place to the right, I'd multiply by 10 to a higher power. Okay, so now I'm looking at 23.45 repeating, and I'm going to run through the same steps we just did. I'm going to call this n this time. And since I have a repeating block of size 2, I'm going to multiply both sides by 10 to the 2. Now in your book, what they do is they're going to multiply by 10 squared, and this here is my n. What I find is that this is sometimes confusing for students, so if you want to just leave this as n here, that's perfectly fine. Okay, so I'm going to multiply 23.45 by 100. And so that gives me 100n equals 2,345.45. All right, now my next step was to subtract n from both sides. So I'm going to subtract both sides. On the right, the decimals cancel. and I'm left with 2,322. On the left, I've got 99n, and now I'm going to divide both sides by 99. Now, this is the rational expression for n, which was 23.45 repeating. That's not the number that we started with, though. So how do I get this number back? Well, this number, 2.345 repeating, is n divided by 10. So I need to divide both sides by 10. Which is the same as multiplying by 1 over 10. All right, so that's what we're going to do here. I multiply by 10 in the denominator, and I'm left with 2,322 divided by 990. And that's going to be the rational expression for 2.3 with the 4, 5 repeating. All right, I'm going to have you try one of these.